Hi everyone, I'm Bastien from ACINQ working on Bitcoin's Lightning Network. I'm going to be giving a high-level view of how it works because I won't be able to go into all the details in 20 minutes, but if you have questions, don't hesitate to come reach me during the break. It's right after lunch, so I'll try to keep you awake. So just a small recap on how Bitcoin works because there are some details that are important if you want to understand how Lightning works. Fortunately, the previous talks already gave a few introductions about Bitcoin. The most important part of Bitcoin that we use in Lightning is the fact that we use UTXOs and scripts. So in Bitcoin, you don't have a balance system like in some other cryptocurrencies, but instead, each transaction has a set of inputs and produces a set of outputs. So you need to be spending existing outputs to be able to produce new ones. And the way you spend those is not directly sending to someone, but it's by each output contains a script in Bitcoin scripting language. And if you want to spend it, you have to give in your input the stack variables, stack inputs that will result in the script evaluating to true. Not exactly that, but something like true. And that allows you to create more complex script than just sending to someone, and that's the thing we leverage a lot in Lightning by using very complex scripts to guarantee the safety and anonymity. The main issue with Bitcoin, as we saw, is that it just doesn't scale. If you want to share every transaction with everyone, and because, as was said in the previous talk, you need the propagation time of every message to be a lot slower than the block production, it limits a lot how many transactions you can put in a block. So you cannot do more than 7 transactions per second directly on Bitcoin, which is what led to creating layer 2 solutions like the Lightning Network. The basic idea is that you don't have to share every transaction with everyone on the network. If you are regularly updating a balance between 2 people, you only need to share the outcome of all those transactions to Bitcoin, not everything. So the Lightning Network is just a peer-to-peer network where it is really based on Bitcoin. That's a very important point in that messages that are exchanged are Bitcoin transactions that could be put on chain directly. Every commitment that is made at the layer 2 is a valid Bitcoin transaction. That enables very cheap instant payment because you only need to exchange those transactions with your peers without submitting them to Bitcoin. And it's a lot more scalable than Bitcoin, but we will show that it is still trustless and secure. The Lightning Network is built on 3 main building blocks. The first one is payment channels between 2 people using a model that's called HTLC, and it's trustless, and we'll show how it works. Then from those, we'll create a network of payment channels to allow you to pay anyone in the network, still being trustless. And then I'll show briefly how the routing works with onion routing, preserving anonymity mainly, and malleability. So first of all, a payment channel. Basically, the way we build a payment channel between Alice and Bob consists of exchanging a lot of messages that are Bitcoin transactions. So if Alice wants to open a channel to Bob with 10 Bitcoin in it, Alice is going to send a message to Bob saying, I want to publish this funding transaction that will be locked to a multi-script, multi-signature output with both of our signatures. Then Bob is going to say, okay, I agree to that, and I'm ready to sign a first commitment takes where I return to you all those 10 Bitcoins because initially the whole balance should be on your side. Once Alice receives that, she will also send to Bob her signature on that initial state, and then she can finally publish the funding transaction to the blockchain. Once that transaction is confirmed, both Bob and Alice can watch the blockchain and see that there's a transaction that is locked to both of them that has 10 Bitcoin. And now the channel becomes available for layer 2 payments. Once that's the case, now Alice and Bob can just directly send messages to each other saying, I'm sending you 1 Bitcoin. I'm sending you back 0.1 Bitcoin. And the way that they do that is by constantly updating a commitment transaction that is a valid Bitcoin transaction and that commits to the balance of a channel. And I'll show in detail how it works in the next slides. once they are done with the channel and they want to close it, they don't need to. The channel can stay alive for a very long time, and I'll show some stats at the end of the talk. Then they negotiate a closing transaction to minimize the fees mainly, put it on chain, and the 10 bitcoins that were locked on chain at the beginning are unlocked and split into a balance, for example, 4 bitcoins to Alice and 6 bitcoins to Bob. So I mentioned that this works using hashed time lock contract, HTLCs, which is, the main idea is that I will give you money against the preimage of a hash. Usually, the payer will generate a random preimage, an amount and a timeout, plus a few other fields, generate a QR code from it, and Alice can grab her phone, scan that QR code, and initiate a payment with all the details that are in there. For example, if Alice wants to buy a picture of a cat to Bob that costs 2 bitcoin, she will tell Bob, I want to buy that, or Bob will say, this is for sale for 2 bitcoin, and out of a network, Bob will publish a QR code that says, if you give me a payment for 2 bitcoin, I will reveal a preimage that corresponds to the hash that is inside that invoice. Now, Alice is going to update her commitment transaction to take into account the fact that she just gives 2 bitcoins to Bob compared to the previous balance, which was 6 and 4, against a preimage to that hash value H. So Alice signs that, and it also needs Bob's signature to be able to be enforced on chain. Now what Bob is going to do, and it's important, he's going to rotate some keys and revoke the previous commitment transactions. And I'll show you in detail afterwards why he really needs to revoke it, otherwise you can enforce old state on the blockchain. Once Alice has that revocation, then Bob will also send his own signature to the updated state that includes the HTLC for 2 bitcoins. Now Alice is going to revoke her old commitment transaction. Yes. And now they both have a new commitment transaction that is signed. Bob's one is signed by Alice, Alice's one is signed by Bob, and they reflect the balance and the HTLC. So now Bob can reveal the preimage that was hidden in the invoice, and they can do what we call fulfill the HTLC. Because if we did that and kept HTLC, we would have a transaction that would be growing each time you had new payments. Whereas in fact, when both have agreed to transfer 2, we can just update the balances directly. And that's what's happening when we fulfill the HTLC. They are going to exchange new commitment TXCs that remove the HTLC and reflect that value in the balances. 6 bitcoin to Bob now and 4 to Alice. And revoke old commitment transactions. That uses just a new private key that is used for each transaction and that is given to the other peer when you're revoking the transaction. And in the end, they reach a state where they both have a commitment transaction with the new balance that are enforceable on chain. So why is it trustless? Because as you saw, we are updating continuously a transaction. What prevents someone from publishing an old transaction to the blockchain when she had more money? For example, what prevents Alice from publishing the first commitment where she had all the balance on her side? The reason is that there is, in fact, a penalty path in the Bitcoin script. Every time you send the other peer a new commitment transaction, you are going to be sending the private key, a private key that was used in the previous transaction, and in the Bitcoin script that was in the previous transaction, there's a short path, there's a conditional branch, where if you have the revocation key, you unlock all the funds in the payment channel directly to yourself. So if Bob commits an old transaction to a blockchain, there's a time lock preventing him from getting the money out instantly, and Alice will see that transaction and is able to get all the money on her side by using the revoked key. So you really have a big incentive not to cheat because you're going to get caught and you're going to lose all your money. So this is a very detailed view of everything that's in the transaction. I will skip over this because I don't have time, but don't hesitate to ask questions afterwards. Just show that basically the Bitcoin script that's in the transaction has a lot of conditional branches and time locks on most of the outputs, so that if you are trying to cheat there's a time lock, and if someone has a revocation key, they can bypass the time lock and get the money out before you successfully cheated. So that's nice, but that's just a payment channel between two people, so it's not really useful if you want to be able to pay anyone in the world. So that's why we have to go from that to a network of payment channels. And the way we do that is quite easy. It's just that if Alice wants to pay Carol, and Alice has a channel to Bob, and Bob has a channel to Carol, Carol is just going to say, hey, pay me 2 Bitcoins. And Alice is going to send an HTLC to Bob saying, I want you to pay Carol those 2 Bitcoins, and in exchange for that payment, I will give you that payment. And they forward the HTLC. Carol reveals the preimage that works the other way, and in the end, the balances are updated correctly. There are a lot of details about tweaking the timeouts and fees to make it economically viable for everyone not to cheat. And obviously, to make it work, Bob will ask for a small fee on the payment because otherwise he has no incentive to just forward it if he doesn't gain anything. And we have to configure timeouts correctly so that if someone cheats along the chain, everyone else is able to redeem their money and not be cheated themselves. And the idea is that with that, anyone that you can find a route to, you can pay. If you know someone in the network and currently in 20 hops, you're able to get to that node, you can send a payment. And what's important is that once we introduce routing and having other nodes relay your payments, you don't want all those nodes to be able to, one, discover who you are and who you're paying to, nor to be able to malleate what you are paying or what you are sending. And in order to mitigate that, we do something just like Tor. We use onion routing, where currently we find the route locally. Every node knows the whole graph and computes a route using source routing, and then does onion encryption on that. Like, we start by encrypting for the last recipient, then for the next to last recipient, next to last. And thanks to that, each node, when they receive an onion payment, they can only peel one layer, find out who the next guy is, forward to that guy, and they don't know where they are in the payment path. So if you are the guy in purple there, when you receive an onion message and you peel it, you only know who sent it to you, but you don't even know if he is the payer or if he is just another intermediate node. And you only know the next node, how much you need to forward, and you don't even know if it's the final payee as well, because it could be just an intermediate node as well. So it guarantees anonymity under a few conditions that depend on how you configure your node. And since it's onion encrypted by the sender itself, no one in the path is able to modify it without violating a MAC. So I'm going to give a few stats about the network as a whole and how it worked. It was started as a purely academic effort in 2013 by Joseph Poon and Teinturier. Then when they released their paper, many people started looking at it, and mainly 3 companies were created that wanted to implement it: ACINQ, Blockstream, and Lightning Labs. Implementation started with those 3 companies collaborating, and it reached the Bitcoin's mainnet in April 2018. Everything is open source. You can find even the protocol itself, and the specification is on GitHub here. All the discussions are open source. We have open IRC meetings every 2 Mondays. Anyone can join, anyone can see the transcripts of the decisions, anyone can submit PRs to that, and all the important parts of the protocols are in there. If you want to implement it from scratch, you just have to read all of this, implement the spec, and it should work with all the existing implementations. As I said, there are a few companies implementing it, with 4 main implementations being compatible on Bitcoin's mainnet. C-Lightning, which is made by Blockstream and is in C, Eclair by us in Scala, LND by Lightning Labs in Go, Ptarmigan by Nayutaco in C++, and the others are work in progress in Rust and in Python. Some stats about the network itself. Right now it's a bit less than 10,000 nodes. It has a few tens of channels and almost 1,000 Bitcoin, which is starting to be quite a lot. Nodes are starting to be more stable, and even channels are more stable because, as you see, 3 months for a channel means you only have to pay the fees for the initial funding transaction, and then you are able to use your channel for many months. So it's really not costly in terms of Bitcoin fees. And what's interesting is that this is just the public part of the network. Everyone who has the Eclair mobile app on the phone is not announced, because if you are using a phone, you don't want to be relaying payments all the time because it would be way too costly, and you're not online all the time. You don't have a bandwidth. You are changing IPs all the time. So there are a lot more private nodes that are not counted into that, and that can still use the Lightning Network for payments. And the core network is still going to grow, but it's mainly the number of private nodes that is going to grow a lot, and people who are able to make payment thanks to that. And I think that's it for my presentation, so I should have time for a few questions. And don't hesitate to reach out afterward if you want more details, because there are a lot of details I had to skip. Yes?
Just a naive question. I'm not familiar with Bitcoin and all this stuff. If you want to transfer from Alice to Bob, say $1,000, and in your network you have only channel of $1, how does it work? Does it mean that each node along the link can place with $1 and you cannot achieve this demand? Or you can spread this demand? Or you can, in practice, transfer $1,000?
In the first version, you need to find a path where the whole amount can go. But there's a proposal that is being implemented and tested right now, which is called AMP, Atomic Multipath Payments, where you can split a big payment into multiple chunks, send them through different paths, and it only works if all the paths succeeded, and then you're able to transfer a big amount of money in one round.
So when you said in a few slides ago that you were able to forward any demand once you can find a path from one node to another, it's rather you have to find
capacity. It's a kind of a mean flow thing, yeah, where you have to find channels that have the capacity to route your payment. Okay. Or you can use AMP to split it into smaller chunks. Okay. If your payment is